The keynote. This morning we have a talk by Alison Randall called Desktop Home Hacks. And Alison is a Debian and Ubuntu developer, retired chief architect of Parrot, and she's a current board member of both the Perl Foundation and the Python Software Foundation, and she spent 25 years in software development. Thanks, Alison.
How about that?
Yep.
Great. So I've been playing with hardware and software since I was about this tall. But last year, as I got more involved with Ubuntu desktop development, I was kind of curious to see what I could do in integrating these two interests in my life. So I'm going to take you along on my journey in the past year as I explored this topic. So there's a few ground rules to this project. One of them is, this is a hobby project. This is not a startup. This is not a product I'm shipping, and therefore it must be fun. One of the key pieces is giving me an excuse to play around with some cool technology that otherwise I might just sort of look at from a distance. The next requirement is it must be open, at least as much as possible. So when I can find an open source or open hardware component to use in the system, that's what I choose in preference to anything that's closed. You'll see there's a few walls along the way, especially as you get down into the lower components where it's just not open and you can't get open alternatives. Another goal of mine was to go for a different kind of user experience. We have, with the desktop, you have a kind of it's like there's a glass wall between you and your computing environment. So I was looking for ways to integrate that more seamlessly into the desktop world. And not only that, but make it feel like a natural part of my environment around me, instead of something foreign. I wanted a way to, well, I can tell you where it started. It started with part of my job is to be available on IRC at all times. If I am at work, the way I define my work is if I am available on IRC, I am in the office. And if I am not available on IRC, I'm not in the office. It's one of the weird things about working from home. But I wanted a way that I could like wander down to get a sandwich or go out to check the mail or whatever and do a few things where I'm not like sitting straight in front of my desktop, but still make sure I was available. So I wanted my computer to reach out into my real life world and engage me, pull me in. But at the same time, I don't want it to be this annoying presence throughout my house. I don't want it to, like if I'm in a focused zone, a flow state, I don't want this, the home pieces or the pieces of my desktop that I've brought into my home to, like I don't want loud klaxons, I don't want Star Trek sirens. I want it to get my attention without being uncomfortable. Another key goal for this particular project was to keep costs down. So you'll see some places where there's alternatives. There's choices I could have made, and I made one choice for making sure that it would be approachable to the general hobbyist. That this isn't the kind of thing that you would install in a professional office environment. But overall, what I was looking to do was blur the lines a little bit to make my sort of virtual self, which is that piece of me that lives inside my computer, more a part of my real self and vice versa. So there's a few key components to this system. One of them is the nodes or motes. My choice for this piece was the G node. So the G node is an Arduino clone. It has all the same components as the Arduino. And it ships like this. A nice kit full of parts that you get to put together yourself. So one of the reasons I chose the G-Node is it's really, really small. The standard, like Arduino Uno, is, it's about this. It's like palm-sized, which means it limits the places that you can hide it around the house. It kind of has a sizable form factor. So I wanted something small for reasons you'll see later. It's really, really cheap. So an Arduino board, you're probably talking $20, $30. And then you have to add on a wireless module, which may be, it can be anywhere from $30 to $70, depending on what you get, whether you go for Wi-Fi or Bluetooth. Whereas the G-Node is $20 for the full package, and it includes wireless connectivity. It's RFM12B, so it's not Wi-Fi. It's a radio protocol, but it allows you to send packets back and forth of a maximum size of 66 bytes. So you're not sending a lot of data, but then if you think about the application space, what you're doing is just sending, maybe a number, say the temperature or something like that. So the amount of data that you're sending back and forth between these little nodes is actually really small. Wi-Fi and a full TCP/IP stack is kind of overkill for this space. So $20, you get your full connectivity between all the nodes in the network and a full Arduino board to work with.
Can you spell it, please?
Jeennode. The next part of the system is the server. So for this, I chose a Panda board, also open hardware. And there's some reasons for that. It is more expensive, a lot more expensive even than an Arduino. It's around $200 for a Panda board. But it's a full ARM processor. And that means I could run a full install of Ubuntu server on it. Now this means that when I'm doing my development for the server, I can just do it on my desktop machine. I don't have to use any special compiling tools. And I've got all of the, in my case it was Python, all of the Python modules available that I might want to use. So what the server does is it collects data from all of the different nodes. So it's got a simple polling system where it communicates with every node in its group, in its network group, and just updates the information that it needs to get from that node or sends commands to that node. So it pulls together information and then also executes the commands that it has, executes the commands to the nodes. It also contains the services for the system, for the home network system, which includes JSON data feed from all of the nodes, as well as a web client interface, as well as the interface for sending commands into the home automation system. And the last major component of the system is the client, or I should say clients. I figured it was better. My life doesn't tend to be spent in front of one machine. I tend to travel around a lot, like even within my house. I will be working for an hour on one machine, and then I'll go get a cup of coffee and stop at another machine, and I'll still be checking the same email or websites, or or I might pick up a tablet or pick up my phone or walk out to the street. So I wanted to make sure that the client interface for my home was one that I could access from anywhere equally well. So this is sort of the one screen, or one part of one screen. It's written using jQuery Mobile, which gives you a lot of nice interface components for free, really easy, which are also, it's got full integration with touch. So if you're working on a tablet, you can do things like, slide the switches. And I've also So what it's running in here for the desktop piece is Chromium has an app mode that lets you open up a web page as if it was a standalone application. So it strips off all that extra useless stuff that you usually get in your browser. It makes it pretend like it's an app even though it's actually a web page. I don't have some pictures, but there are some components behind this. I did some experimenting last year with controlling your desktop from your browser. So I've got a little Vala web server using libsoup and libunity that accepts JavaScript commands and does things like pops up your launcher icons and changes the status and gives you little alerts, or you can set, like, there's a number you can put on launcher icons. So you can say, I want to track the temperature all the time. Just have that icon track the temperature for me. So it gives you a little more integration. There's some other components that are really interesting for doing that. Mine was just a little prototype that I wrote. Seed is a really interesting one. That gives you like pretty much full access to GTK underpinnings from JavaScript, which is quite cool. It does require a patched version of the WebKit browser though. So I was looking for something I could do a little bit more independently without altering the main desktop components. So those are the major components of the system, nodes, server, client. There's a whole bunch of different components that you can plug into one of these nodes. The main ones that I chose on the input side were temperature, so tracking at various places in the house what the temperature is. One of the inspirations for this is I travel a lot, and several times over the past couple years I've been away from home. I'm not coming back for another 2 weeks, and for some reason my desktop machine at home, which I'm SSH'd into doing some kind of development work because it's got a more powerful processor than my laptop, disappears. Just completely disappears. And the suspicious thing about it was always in the middle of summer. And I tend to turn down the air conditioning a little bit when I leave because I'm not in the house, so why should I leave the air conditioning on? So I'm pretty sure, and I'll test this theory this summer when it gets hot again, I'm pretty sure that what's happening is that my office is getting too hot, the machine is overheating and it's shutting down. So I wanted to have a way of remotely tracking the temperature in my house, particularly in my office and server closet there. This is a terrible photo of a humidity sensor. Humidity sensor, it's not necessarily as immediately practical, although I did once go on a trip for 2 weeks and come back and find my kitchen entirely flooded. So it could be handy to say, wait a minute, why is it like 80% humidity in the house? That doesn't make any sense whatsoever. That's like approaching rain levels. So that was just a little thing to throw on. This is a motion sensor. The main use for that right now is basically room detection, like human presence detection. So we have a human walking from one room to the other, and you can do things like turn lights on and off depending on where the person is in the house. To save power. I have a really bad habit of leaving all the lights on and then, like falling asleep on the couch. And I don't know, I feel bad about that. I realize there's not that much power being consumed in 12 hours of leaving the lights on overnight. But it just seems like if you could capture that tiny bit of power, it's a small contribution to the world. It's also more convenient if you're wandering around the house, like carrying equipment or something, to have the lights just come on as you walk through instead of having to manually flip things on. This is an RFID reader. I have to say, one of my great disappointments with deploying RFID was the range. People talk a lot about like, ooh, somebody's standing across from you in the airport, scanning your passport. The fact of the matter is, you have to be, for the passport level, this is about as far as you can get with any RFID reader available today. And most of the ones you buy here, like most of the ones you buy like off the shelf, sort of consumer level equipment, you have to be this close. So it's not quite as miraculous object detection as you might hope. But I did deploy it specifically for object detection. I have a bad habit of losing my wallet. I know it's somewhere in the house because I walked in the door with it, but I don't know where. So I was hoping to have it, like I could have one reader node in each room and just kind of have it detect that the object was in the room. It's not quite that good, but I can put them in doorways, and then I can detect when I've carried it from one room to the next.
So that feeds into home Google, does it?
Google my wallet, yeah. But the RFID chips themselves come in all sorts of amazing form factors, like just about anything you can imagine. You can have them implanted in your skin, but they often also come in, like little tokens that you can, like throw around and things. This is my favorite for object tracking, and that is, it's just a sticker. It's like a plain old piece of paper sticker, and it's like pieces of tinfoil in the back. And that is the chip itself. So it's completely flexible, very light, and it's got one adhesive side, so you can stick it inside your wallet. It's not going to slide out along the way. This is a touch sensor. It was designed for wearable computing. I've been using it for a slightly different purpose, and that is, I would say, decorative computing. This particular node is now in a throw pillow that sits in my living room, and it gives me the ability to like turn off alerts when they get annoying. It's only got four touch sensors, so it doesn't take a whole lot of different options, but it gives you a little bit of a sort of a natural interaction feeling. This is an amazingly small, full Bluetooth USB keyboard with a trackpad integrated, which is pretty cool. It's, it fits in the palm of your hand. Actually, my hands are pretty small, so for your hands, it'd probably be, like within your fingers kind of space. This I mainly use for the Panda board server, so I don't have to have I don't need to interact with it much, but it's nice to have a keyboard plugged in all the time just in case I need it. So some of the components I chose for output. The photography doesn't show very well. It's about a hand-sized plastic egg. Yeah. With it does multicolor LEDs, so you can actually have it shift between different colors for different alerts. And it just kind of it sits on your shelf. It looks like a collectible object or something like that. But when you need it to interrupt, it can give you some information. But it's a very gentle, the way it changes colors is very gentle, graduated shading. So it doesn't like flash or anything like that.
What's that called?
That?
Yeah.
I don't really have a name for it.
Did you make it?
Well, I bought the case, yeah.
There's a version you can buy called the ambient bulb.
Oh, and I should say the egg is one of the pieces that's tied into IRC for me for like different colored alerts depending on whether they specifically messaged me or it's just there's a specific word that I'm tracking in IRC. This right here is called a power tail. It has a little 5-volt input to control whether or not the power is passed through, but you never touch the 120, 110 or 220 volt power. It's like it's completely isolated from you. So it's a very safe way of controlling power in the home. I mean, there are other things you can do that are like more detailed installation, or you can actually build your own. But I liked this one because it was cheap and inexpensive, and it's like I wouldn't mind if my son was playing with that because I know it's safe and fully isolated from the wall current.
What's it called again, and does it support 240 volts?
This particular one is 110. I didn't check and see if there's 240 volts. You might ask the next talk. You might know.
What was it called?
This one is a power tail. There's a couple of different ones that I found. And then I started experimenting more with camouflage. So this is an ordinary home candle. You might find it on anyone's shelf or table centerpiece. But it's been gutted. You can't really see it very well. It's been gutted and replaced with LEDs. So that's a trio of LEDs there in the middle. And so the candle is tall enough that you can actually fit a fair amount of electronic components inside the body of the candle, and it's pretty much hidden from view around, including like AA batteries or whatever you need inside. This is another interesting substance called Instamorph. It's plastic that at a temperature of water that's cool enough that you can stick your hand in it, but warmer than average, ambient room temperature or water. It changes consistency so it's hard at room temperature, but at slightly warmer temperatures, it mushes. So you can actually build things out of it. You can think of it as a poor man's 3D printing solution. I did look at the 3D printers, and I will not be able to resist buying one for much longer. Well, I've been tempted to buy one for years now, but at close to $1,000 a piece, I thought that really didn't fit in with the affordable goal for my project. So I went for alternative solutions. This is another substance that when you get it, it's kind of like modeling clay. It's not soft, it's not gooey, but you can shape it however you want, and then you bake it in an ordinary kitchen oven, and it turns hard. It's also slightly translucent, so that you could have LEDs inside whatever you build. I haven't really done much artistic with it yet. I've gone for like dome shapes and box shapes and nothing too, but you could go totally crazy, like, I don't know, the head of Beethoven or whatever you want. One of the fun things about this project was an excuse to be hands-on. So I spend most of my time in virtual reality and software where you're just looking at lines of text and then building something that just displays on a screen, and that's all you ever do. So it's really kind of refreshing to take a step back from all that and have your hands on stuff. So there was a lot of different tools, but this has always been my favorite tool since I was about 3. If you have small children, watch them carefully, but it's a lot of fun to melt solder over water and see what kind of shapes it forms. Little kids love that. And I just started acquiring things from various stores. You end up with collections of wires and chargers and little bits of clips and components and fuses and, I don't know, screwdrivers. This is probably the weirdest set of tools I collected. They look like horrible dental instruments, but they're actually, they're designed for carving wax, but they work just as well for the moldable plastic or the clay solution. They're really quite scary, though. So this is really just the beginning, right? I've only been hacking on this for almost under a year now. Some of the lessons I've learned along the way, I really, really need to pick up a digital SLR with a macro lens. You may have noticed some of my fuzzy, kind of odd colored photos. Those were actually done with my Android phone because my Android phone did a better job of taking photos of tiny electronic components than my little handheld digital camera, for whatever reason. The macro lens. Ooh, really, really need to work on lighting. So the only way I was able to take photos of these at all is pick a sunny day, which is hard to find in Portland in the winter. Open up the windows, like set my table right underneath the sun and get as much sunlight as possible onto the devices. So I was hoping to bring some stuff for folks to play with after the talk, just kind of lay it out. The fact of the matter is, so I was flying standby, I only had my carry-on luggage, and they nearly didn't let this through. This is like an Apple Magic trackpad. There's nothing threatening or scary about it. It's smooth, you know, it's clearly a consumer device. I can't imagine what they would have done with some of my bizarre concoctions of wires and so we'll see. I might be giving the talk next year in Portland, in which case then I'll have everything nearby. I could just ship a whole box full of stuff into the convention center. And none of my work right now has been released at all. I mean, a lot of it is building on fully open source components, but I just haven't taken the time to, I'd say, polish it, document it, and bundle it up so that I can put out a tarball or even package it up for Debian or Ubuntu or something like that. So there's the software side. On the hardware side, I mean, I've really just been putting stuff together myself. You know, it's a bunch of random wires and bits and pieces. It would be cool, and I was actually talking to Jonathan Oxer on Tuesday, it would be really cool to take some of these units that I've built and convert them into like a standard Arduino shield. It's apparently quite easy to lay out your board and get it printed. So I may be doing some of that in the next year or two. So if you're interested in taking a similar journey yourself, I can suggest, I'll put my slides up. I'll make my slides available so you can get all of these links later. But some things that you might want to look at, these are some of my favorite sites. Adafruit has a whole bunch of components and designs and tutorials on how to build stuff. SparkFun as well is good. Parallax has a whole lot more like low-level components. That's where you'll find a lot of the like temperature sensors or motion detectors or humidity. They don't have a whole lot of open stuff, so I really only went there as a last resort, but it's a good resource. DigiKey, Panda boards, Panda board chargers, and they don't have a very good interface, so it's hard to find it, but they have some amazing components available on there. I usually end up finding it somewhere else and then going to search on their site by part number, and then I can find what I'm looking for.
Or to their catalog. Easier to use the paper catalog.
That's probably what they expect. They're probably still in the old days of paper catalogs, yeah.
Have you seen Octopart?
No.
Octopart searches, I think they search DigiKey, Mouser, a bunch of other sites and do comparison shopping for components.
Oh, very cool. Just Octopart.
Octopart.com.
Makershed has a lot more of a consumer focus. I mean, it's especially like really around kids, getting kids engaged with hardware and software. But they do have a lot of cool stuff that you can buy there, usually more towards the kit side than like individual components, kits and tutorials and that kind of thing. They have a magazine too. And one that I just discovered this week. Which I have to say is like the coolest swag ever to get. So a couple of other immediately available resources. Right after this talk, Jonathan Oxer is talking a little bit more about some hacks with actually developing components for your Android phone. And then right after lunch, Philip Lindsay is going to talk a little bit more about low-level details of getting involved and working on this kind of stuff. So some of the open components that I used. This talk was developed, these slides were developed in an Inkscape plugin called Sozy that lets you take any arbitrary SVG and block it off into slides so you can organically travel around the whole SVG. A lot of photo editing in GIMP. Processing, the Arduino development IDE is actually sort of a modified version of the processing IDE. It uses the processing language, which is it's a pretty cool little language for lightweight development. Python was all the server components, any kind of like back-end pieces that I had to do. Also the JSON generation and parsing. And I mentioned Vala was the little micro web server for integration between JavaScript and Unity, the Unity desktop components. jQuery Mobile has just been released as 1.0, and I have to say I am really impressed with it. It's like a really stripped down version of jQuery that's totally focused on like phone and tablet interfaces. And that's it.
Well, we've got quite a bit of time for questions, so I'll have to run up the back here to start with.
Hi, first of all, thanks for crediting how you made the slides. I was going to ask that. I'm curious about RFM12B. I haven't heard of it. I'm particularly... I just moved back to Sydney from San Francisco, and I felt bad about leaving all of my X10 gear behind because it runs on 110 volts. It's clunky as it is. It's really cheap. Here in Australia, it's prohibitively expensive on 240. So I'm wondering if it's a kind of RF that I could interface with at least my X10 motion sensors and those sorts of goodies with.
You could. I mean, the question is about integrating the radio module that Gnode uses with X10. You could do it. You'd be a little bit on your own for the interface component. There is no direct integration from this particular radio module to the X10. But you could have a server in between. Like, you can plug any of these systems back and forth together as long as you're willing to have a Linux server in the middle to translate between the different components. So you would probably need a server that's connected to your X10 network, and then a server and the same server connected out to the Gnode or whatever else you decided to use. There's actually several different systems that you can use other than like X10 is one of them, but there are some, like Zigbee is another one that's more recent. I avoided Zigbee because it's not open, and also it's expensive, yeah. So I kind of went for like a manual self-hacked version of the Zigbee or one of the other wireless systems.
We have a couple of questions down the back before we get to the man at the front.
Just going back to your throw cushion with the sensors in it, that's obviously a wireless Gnode module, yes?
Repeat the question?
The throw cushion, you said, that had some sensors in it?
The what that had some sensors in?
Cushion. Throw.
Oh, yes. So that's got a Gnode inside. So it's connected with a Gnode inside with like a hard casing.
Yeah.
So that.
Just wondering, that's obviously battery powered. Have you had any thoughts about mitigating the need for batteries in remote sensors and those kinds of things? Like, how often are you changing the batteries in this?
For everything that's a hard installation, I try to use wall power. Batteries, I haven't had to change the batteries yet. it's pretty low power consumption. All of like the G-Node, like the Arduinos even are really low power consumption. I would love to figure out some alternative strategy for powering these things, but like, yeah. Air power.
And all the computer stuff.
I do turn it all off when I leave the house for weeks at a time, which I do fairly often.
There's a lot of interesting stuff there for sort of for your own use. So as you travel around the house, you can see, oh yes, that little thing is glowing blue, and that means I have a personal message or something like that. What have you given much thought, and what ideas do you have for guests to the house and other people that might live there, how they can interact with it and how they can find out stuff about it?
That's a very interesting question. I haven't actually. I haven't thought about, which is kind of odd, because my first exposure to this kind of thing was staying as a guest at someone's heavily X10 modified house and like wandering around the house trying to figure out how to turn the lights off. I think so. Part of the next plan, and I think that may be part of it, is doing the central home server, right? So it's like you have big screen TV, a machine that's powerful enough to be your home media center, hooked into your audio and all of that, and also have that with, there's some new interfaces where it's almost like touch, but it's just in the air, Microsoft Connect or some of those things, and have that so it's so that control panel, although a more complex version of it, would be up on the central screen of the house. So they would kind of have a little more discoverability into it. Whereas right now you kind of have to know to go to the right website that's hosted internally and remotely.
So I know Myth TV has some of that kind of integration with home phone servers and that sort of thing, but that's still an interface. You have to say, the TV has to be on, and it has to be on the right. You have to have the right keyboard to be able to talk to it. Sort of thing. So.
There's some interesting things you could do. I mean, you could do something like, let's say, keep a bunch of spare Android phones around, and when they enter your house, it's like, here you go. This phone is your key to this house. This will let you turn the lighting on and off. This will let you in the door, because you can actually have doors controlled by like RFID or signals sent into the server as well. And it's like, this is your personal access passport to my house. Welcome. That would be cool.
I'm actually setting up a web interface for mine, but what I did in San Francisco was I sent a link to a tutorial about how to use the button, so if they woke me up in the middle of the night, I could say RTFM.
I may have missed you mentioning this during the talk, but the RF protocol you're using to communicate between your individual devices, is it secured? What stops your neighbours from turning your lights on and off?
Nothing at the moment, except for range. It doesn't have very good range. And a lot of obscurity, in the sense that they would have to actually know to buy a G-Node and know the specific commands that I'm using for various things, because it's just like a 1-byte command.
Security through obscurity doesn't work.
And also, at least my house is not like throwing knives on command or anything like that. So they don't actually have access to anything harmful. They can.
Pillows are mission critical. My house is haunted.
The lights keep flicking off and on.
Hi. I couldn't quite build a picture of your full architecture from that, so I'm not quite sure. How many transmitters are you using versus receivers, and do you have any problems with contention on the I guess you're on 915 in the US, right?
I have, so G-Node has a cap of 31 elements in a group. So the Panda board has one receiver. Well, actually, any G-Node can be a sender and receiver, but essentially the Panda board is the receiver, and it just it does polling, so it just talks to each one in turn. It asks for the latest update. So that it's a little bit. I did go for a little bit more structured approach because it doesn't have, like, I only have the one receiver. It's not like a web interface where I could fork off a whole bunch of Apache children and be receiving a whole bunch of data at the same time. It's really just one send and receive for each node. But you know, there's actually only about 17 of them right now, so it can do a full poll pretty quickly.
Next question.
Hey, how does the Genode system actually work? And is it the kind of thing that you can sort of interface directly with an Arduino and an antenna?
It is an Arduino. So the Genode is, there's the fact that the Arduino hardware is open means there's been like a huge explosion of sort of forks and modifications. So what the Genode is, it's exactly the same hardware as an Arduino Uno. But the board itself has been miniaturized. It doesn't have the full plug-in for the Arduino shields. So a lot of the space on the Arduino board is like for the shields, you know, to make a standard interface for shields to plug into. So it's all been shrunk down to a tiny little space, and then it adds the RF module. It's a surface mount directly on the board. So it's part of the whole board there.
By the way, I just wanted to plug Little Bird Electronics, add them to your list of resources. I found the cheapest place of really cool components in Australia.
Cool.
More questions?
Please don't take this the wrong way. I'm not trying to be too critical, but maybe just as an improvement in future talks, it might be more awesome to have more of an explanation of the awesome system that you built and more detail about how it works and everything, because we don't really need a picture of a soldering iron. So maybe, I don't mean to be
actually
too
that,
rude,
that's a
but
very
maybe
good
we
point,
could-
because I spent a long time thinking, well, how do you make a talk like this interesting? So I do have, well, I wouldn't say I have. I could have done, and I'll eventually put it up on the website, like extensive schematic diagrams and a detailed architecture of how all the components work together, and maybe a bit of tutorial. Actually, the tutorial you should wait for the next two talks. We kind of talked about it on Tuesday and decided that we could leave the tutorial to their talks. But talks get really, really dry really easily when you're talking about that. But if you're interested, I will put up the web page in the next couple of days with a listing of all the components and schematic diagrams.
Just mentioning does sound really interesting and not dry.
I can vouch that Luke does mean well. He's not being harsh.
Oh yeah.
I'd like to suggest maybe a little bit of embedded video, perhaps, of your house.
No, I don't have a video camera,
Yeah, maybe,
but that's I can add that to my list, my future list.
And recommend that you don't present in Portland until you tighten the security up a bit.
Any more questions?
So for things like the going back to the throw pillow, because that's really cool. Have you done any optimization for power management, like putting it into sleep and only waking it when a button's touched and that sort of stuff? Or
I
have you
haven't,
not thought
no,
about
but
it?
that would be really interesting. Yeah.
So,
I don't. So yeah, one of the limitations of the G-nodes is you're not going to get like a wake on LAN interface. So it's either on or it's off, and that's the only option you get. But with something like Wi-Fi, you could, like if you were using Wi-Fi modules, many of them do have some kind of wake on LAN where it just kind of drops down into a suspend mode until it receives a request.
okay, so is there output on the pillow as well, or just input?
Is there what?
Output,
On
the throw pillow.
Well, so the output is when you touch it, then it. Oh, I see what you're saying. Does it receive? Well, it has to receive signals because it's a two-way communication, right? It's just sending packets back and forth.
Yeah.
So it receives a request for information, sends back information, or it's also push. So you touch something and it sends a signal.
Yeah.
Well, actually, it stores a state that it's been touched. So the next time it's pulled,
that's what I thought.
The state gets updated. Yeah.
If you put a little pager vibrator in your pillow, when you hug it, it can give you a little hug back. Or just an acknowledgement that you've actually touched it in the right place.
Well, I mean, you could do things. You can wire, like they have special fabric LEDs that you can like wire into the. So you could have it, like when you touch a certain section, it gives you responsive colors so that you know that it has actually received that touch.
I'm just curious more on the network that you talked about, or the wireless. 2 questions. You said it's not 802.11 anything, so how does that interface back to the Panda board server?
The Panda board has a G-Link, which is basically just a little G node on a USB stick that plugs into its USB port, and then it communicates back and forth with it.
And that network that it does implement, it's a mesh network, so they don't all have to be in range of each other, just in range of another one?
It's not, no. It's direct communication between two. They each have their own unique ID, and it knows which ID to ask for back and forth. But it's a fairly small space in the house.
Any more? No, very good. Okay, I'd like everybody to thank Alison for a very interesting talk. Alison, on behalf of the Linux conference today, I'd like to present you with a little gift as a remembrance of this.